Previously, we discussed the fascinating world of generative AI, exploring how it mimics human creativity by learning patterns from existing data. We delved into its historical evolution and its significant applications across various industries, including healthcare and retail. We also touched upon the ethical considerations that come with its use, such as data misuse and bias. Today, we are going to dive deeper into understanding the differences between generative and discriminative models, which are fundamental concepts in the broader landscape of artificial intelligence and machine learning. Let's start by exploring what generative models are. These models are designed to generate new data points by learning the underlying distribution of the training data. They focus on the joint probability distribution of input features and their labels. This capability makes them particularly suitable for creativity-driven tasks, such as generating images, music, or text. Some key examples of generative models include generative adversarial networks, or GANs, which consist of two components, a generator and a discriminator, that compete against each other to create realistic data. Another example is variational autoencoders, or VAEs, which encode input data into a latent space and then decode it, allowing for data generation through variations. To put it simply, you can think of a generative model as a chef who learns a recipe by understanding the ingredients and their combinations, experimenting to conceive new, similar dishes. Now, let's shift our focus to discriminative models. These models are oriented towards classification and prediction tasks. They learn to classify data points by modeling the conditional probability of a label given certain features. This focus makes them excellent for applications such as image recognition, speech recognition, and spam detection. Examples of discriminative models include logistic regression, which utilizes input features to predict the probability of a categorical outcome, and support vector machines, or SVMs, which aim to delineate optimal boundaries between classes within a dataset. If we were to use an analogy, discriminative models are akin to food critics who evaluate and categorize dishes based on culinary criteria without devising a new recipe themselves. To further clarify these models, let's consider a comparison. Generative models are designed to generate or simulate data, while discriminative models are used to classify data or distinguish between categories. Generative models approach this by modeling the joint probability distribution, whereas discriminative models focus on modeling the conditional probability between features and labels. In terms of applications, generative models are used in image synthesis, text generation, and simulation, while discriminative models find their use in image recognition, sentiment analysis, and fraud detection. Some example algorithms for generative models include GANs and VAEs, while logistic regression and SVMs are examples of discriminative models. There are some common misconceptions about these models that are worth addressing. One misconception is that generative models are better than discriminative models. The truth is, the choice between generative and discriminative models depends on the task's specific needs. Generative models aren't inherently superior. They offer different capabilities. Another misconception is that generative models only generate data. While their core feature is data generation, they also enhance data representation and address missing data issues. Here are a few tips to keep in mind. Utilize generative models for understanding data distributions or generating new instances, and select discriminative models for tasks that require accurate classification and prediction. The growth of generative AI has spurred innovation across multiple domains. In art and creativity, generative models generate artworks, compose music, and design products. In healthcare, they produce realistic medical imaging data, aiding in training and diagnostics while maintaining patient privacy. In natural language processing, they enhance chatbots and virtual assistants by generating coherent, human-like responses. Looking to the future, emerging trends indicate a promising future for hybrid models that leverage both generative and discriminative strengths. These hybrid models stand to offer robust solutions in intricate areas like autonomous systems and personalized medicine. In conclusion, a solid grasp of generative versus discriminative models serves as an essential foundation for AI enthusiasts and professionals. Understanding these nuances equips practitioners with the ability to deploy the most suitable tools, fostering efficiency and innovation in AI-driven projects. Next time, we will explore how generative models learn joint probability to create new data and how discriminative models focus on class boundaries to optimize classification. We'll also look into their applications in text, image, drug discovery, anomaly detection, sentiment analysis, object recognition, speech recognition, and predictive maintenance. Stay tuned for more insights into these fascinating models.